I'm Garima Tripathi, Assistant Professor, RKGIT. Today we shall be discussing on the topic purification methods for crude drugs under the subject Pharmacognosy and Phytochemistry-II. So purification is a chemical context, is the physical separation of a chemical substance of interest from foreign or contaminating substances. Pure results of a successful purification process are termed isolates. So all these days we had been discussing few things under this unit, that was extraction, isolation. So here what it suggests is that once a pure result of successful purification will result into the substance termed as isolate. That means once the isolation process is complete, we get one pure substance and that is termed as isolate, and various techniques are used to achieve this. After the extraction of the crude drugs from the plant, the need of marker components to be isolated and identified is also equally important for the study with respect to chemical nature or even for the development of newer formulation. So this particular method is highly important to achieve this goal of isolating markers, identifying them, and to utilize the isolates for the various formulation development methods. The advances in the field of chromatographic technique and other physical and chemical methods have enabled the separation and purification of the compounds. Methods of purification. Physical methods include chromatographic separation, Droplet counter current chromatography, or what we call it as DCCC, distillation, evaporation, crystallization, sublimation, and precipitation. There are methods which are termed as chemical methods for purification. It includes hydrolysis. This hydrolysis can be achieved by acids, alkalis, or enzymes. So acids and alkalis and then enzymes. There are various enzymes which act on particular type of substances and release them. So like some of the glycosides, they are treated with the enzymes so that their A-glycon and glycon, that is the sugar and non-sugar part, could be easily separated out, and more biologically active A-glycon could be isolated. So another chemical method is salt formation. This technique is generally used for alkaloids where salts are prepared, and then we do have acetylation. We'll thoroughly go with these methods of purification. The first one is the chromatography. As already chromatography is a lab technique which is utilized to separate the components by distributing them into two phases. The one of them is stationary phase, which is fixed, and another one is the mobile phase, depending upon the relative affinities of the components for two phases. Stationary phase may be solid or liquid, supported by solids, gel, liquid supported or by solid. Mobile phase may be liquid or gas. Let's repeat. Stationary phase may be a solid gel or liquid supported by solid, a gel or liquid supported by solid. Mobile phase may be liquid or gas. Planar chromatography, like paper chromatography, thin layer chromatography or TLC, and HPTLC, that is high performance thin layer chromatography, and column chromatographies, which are also called as open column chromatography. Like examples of this open column chromatography are the GC, gas chromatography, HPLC, high performance liquid chromatography, ion exchange chromatography, gel chromatography, flash chromatography are two main types of chromatographic techniques. So outlining the information given here, there are two techniques. Number one, either planar or the open type of open column type of tubular chromatography. All the chromatographic techniques where a 2D plane or plate is used and that is surface is used, like paper or glass plates or plastic sheets or aluminium sheets in case of TLC and HPTLC, come under the category of planar, while the tube-like chromatography techniques including GC, basic liquid column chromatography, HPLC, IEC, gel chromatography, flash chromatography all come under the category of open tube chromatography. Next is this droplet counter current chromatography. This is recently developed of all the discussed liquid separational techniques based on the partitioning of solutes between a steady stream of droplets of mobile phase and the column of surrounding stationary phase. We shall illustrate with the diagram in the coming slides. It is particularly indicated for the preparatory scale separation of polar compounds and has been applied to the isolation of various types of natural products. DCC is based on the combined principle of liquid-liquid extraction and the column chromatography. It is a simpler modification of counter current distribution, that is CCD, principle of chromatography, which was developed by Craig, and the apparatus that was utilized by him was called as Craig's apparatus. Here the mobile phase moves in the form of small droplets. Unlike the CCD, in Craig's apparatus only there were two liquids, upper layer and lower layer, which was mixed, and then the separation took place due to partitioning. But in case of droplet counter current method, instead of utilizing two layers, the stationary phase with the sample in the form of drop is passed through the mobile phase. Hence, the solute separates by distributing between the stationary phase and the droplets, which is a mobile phase as well as the sample, according to the partition coefficient difference between them. Stationary and mobile phase moves in the counter current direction. Counter current, that means in the opposite direction, like the mechanism in the if you have studied in HAP, the counter current, like in kidney, the movement is in one coming from this end, and the after it is in the Henle's loop, it goes in the opposite direction. So that is called as counter current direction. And next is chloroform, N-butanol, N-heptane, methanol, ethanol, acetic acid and acetone are solvents leading to efficient droplet formation. This multi-step extraction technique consists of about 200 to 500 vertical columns which help to separate the mixtures where partition coefficient differences are very small. DCCC can separate milligrams to grams of the constituent in a very short time. Let's illustrate the two techniques. This is the Craig's apparatus, which is you can see here the series of tubes are kept, or you can also say that these are the tubular trains. The tube which was being utilized for the Craig's counter current separation looks like this, and this is blue is the lower liquid, while the pink is the upper liquid. Initially at time 0, when the first tube, you can see there is no component in the moving phase, while there is one component in the lower phase. Once the separation starts or the transfer takes place, the complete separation of the moving liquid will be transferred with the binomial equation or with according to the binomial expression. The other one is the Doppler counter current method. Two types of Doppler counter current chromatography has been shown. One is ascending mode, another is descending mode, depending upon whether the mobile phase is heavier or lighter than that of the given sample. And in this, first the sample is sent through the column, and then in the form of droplets. These droplets, instead of the layer of the Craig's apparatus, a droplet along with the sample is released. This droplet will move through the column, and while moving through the column, there will be partitioning and separation of the material. Further, this droplet will move into tube T2, then tube 3, 4, and likewise some 200 to 500 such tubular arrangements would be kept, and finally the separated it would be collected at this stage. Next is, as this solvent system is already discussed, we move to our next technique, that is distillation. And distillation, it can be water distillation or steam distillation. It is specifically essential for the separation of essential oils. The heating or plant material with water in a distillation unit, the vapors of volatile oil components are passed towards the condenser along with the stream of vapor. The oil and water layers separate on cooling. This method is not suitable for volatile components as they deteriorate because of prolonged boiling at high temperature. So here are the two apparatus that is being shown for water distillation and steam distillation of oil. So as said, water distillation is generally used for essential oils in common, though there are sophisticated instruments available for better separation of volatile oils. Here directly the component is heated along with the water, along with steam generated. The volatile component passes through the instrument, it gets condensed out and finally is collected in the receiver. Now here with time, on cooling, the water and the oil would be separated out. This particular separated oil is collected in the different receiver. The apparatus is the Clavinger's apparatus for separation of volatile oils. There are variations available depending upon the specific gravity, whether the volatile oil is heavier or lighter than water. Then we have this steam system, where first the water itself generates the steam. Here no plant material is added. Once the generated steam is allowed to pass through the fresh, generally it is a fresh plant material utilized here, and then this steam will along with it carries the volatile component and come to the condenser, and finally the separated volatile oil is collected. Next method is evaporation. This method, substances dissolved in a liquid phase are removed by binding to a membrane. That means a membrane is being utilized. This membrane will to that the substances dissolved in liquid phase is adhered, and there are two types of membrane. One is hydrophilic and another one is hydrophobic membrane. The hydrophilic membranes may be used to remove the polar materials including water from the organic solvents. Conversely, hydrophobic membranes can be used to remove organic compounds from an aqueous phase. This method has been used to remove aroma from the fruit uses. This method is currently being developed and its success will depend on the generation of new membranes which show selective binding for particular chemical groups, perhaps even for specific enantiomers. Sublimation. In this process, some substances on heating or cooling change from solid to gas or vice versa without passing through a liquid state. This property can be used to obtain the substance from dried plant material or a dry crude extract. Plant material is warmed and vapors are allowed to come in contact with cold surface. The subliming substance vaporizes from the plant material and is condensed as solid on the cold surface, from which it can be easily scraped off. Caffeine of high purity can be obtained by this method from dry tree leaves. Similarly, a very household example is camphor. Camphor is also prepared and can be easily extracted using this method. The only thing is that it gets vaporized directly without coming to liquid phase, adheres to the glass surface, and once it adheres on cooling, it changes its state from gas to solid. It can be easily scrapped off. Next is crystallization. Crystallization is simply a collision process where the molecules collide to form clusters called the nucleus, which then forms the crystals of characteristic internal structure and external shape. This is the most preferred method of separation and purification of natural products. From the mixture, crystallization involves supersaturation of mother liquid and nucleation to affect the crystal growth. For supersaturation, the saturation solubility rises within the rise in the temperature. Following methods of skillful evaporation or cooling can bring out good quality of crystals. In evaporation, the saturated solution is kept open at a constant temperature, on the rate of evaporation is slowed down or increased by covering the perforated aluminium foil or directing gentle stream of nitrogen gas over the solution surface respectively in the cooling process. The degree and rate of crystal growth formation can be controlled using this. The rapid cooling yields microcrystals of excessive number of nuclei, hence a large number of small crystals are formed. Vapor diffusion is alternative method for slow evaporation and slow cooling. Next method is precipitation. Precipitation is different from crystallization, where insoluble compounds is formed in the solution by a chemical reaction. To achieve specific separation, it is necessary to control concentration of precipitating agent so that the solubility of only one substance is exceeded. Alternatively, a second agent or masking agent can be added to the solution to form stable soluble products with one or more components in order to suppress the precipitation in the precipitation reaction. Alkaloids are generally precipitated using tartaric acid of different pH for different alkaloids. Next is chemical methods of purification. First among here is hydrolysis. This means chemical cleavage of chemical bonds by the addition of water and or acid, base or enzyme. Glycosides are generally purified by hydrolysis. Acids and base are useful in saponification and other hydrolysis processes. Enzymes that hydrolyze glycosidic bonds are called
glycoside hydrolases or glycosidases, and these are applied for the separation of many glycosides. Next is salt formation. Forming salt from free acid or base is the most common method. The free acid or base of a drug substance is combined with the counter ion base or acid in specific molar ratio in a suitable solvent system. The salt form then are crystallized and isolated under favorable conditions. Alkaloids are generally purified by this technique. Next is acetylation. So, acetylation, acid alkylation refers to the process of introducing an acetyl group resulting in azotoxic group into a compound, namely the substitution of an acid group for an active hydrogen atom. A reaction involving the replacement of the hydrogen atom of a hydroxyl group with acetyl group yields a specific ester, the acetate. That means once the acetylation is done, specific along with the hydroxyl group, the acetates are formed. Then acetic anhydride is commonly used as an acetylating agent reacting with free hydroxyl groups. For example, it is used for the synthesis of aspirin, heroin and THCO hyphen acetate. Let us recapitulate the concept of purification. So, purification in chemical context is separation of a pure single component or a set of pure chemical substances successfully through the process of purification, and this is termed as isolate. Then we had studied that there are two methods, among them are physical method of separation with chromatography, DCC, evaporation, crystallization, sublimation, precipitation, etc. So, chemical methods include hydrolysis, salt formation and acetylation. Among the physical method, one very important technique is the chromatography, wherein we are having planar chromatography, we are having column chromatography, and in planar chromatography the examples as already discussed TLC, HPTLC, paper chromatography, while open column chromatography are Doppler, CC, HPLC, and gas chromatography. So, next this important discussion was on the Craig's apparatus and Droplet countercurrent chromatography, wherein droplets were being utilized to transfer or distribute the sample present in them into the mobile phase, making more efficient and effective transfer of the isolate or effective transfer of the substance, which could be utilized for the analytical purposes. Next was distillation, which is generally performed for the volatile oils, and though this is not a very good choice of purification for volatile oils. Then we had evaporation of substances, where liquid phase was removed from a membrane binding it. So, there were two membranes, hydrophilic and hydrophobic, to remove polar and non-polar substances respectively. Sublimation, this was carried for either camphor or caffeine from the tea leaves and camphor crude drug, that is Camphora tamala. So, wherein the substance directly goes into the gaseous phase from the solid phase and vice versa, and is collected with scrapping. Crystallization, this is another very well utilized technique for purifying the isolate. So, wherein collisions result in smaller nuclei, and this could be controlled. The growth of the crystal can be controlled by slowing or increasing the evaporation pattern. So, if rapid cooling will result in the microcrystal formation, while precipitation is the most well utilized way of separating the isolate in case of alkaloids and others. Similar are the chemical methods. Hydrolysis, which is actually practiced mainly for the glycosides like cardiac glycoside, digitoxin, etc. Then we have this salt formation. Salt formation is again utilized for the alkaloidal separation. Then we have acetylation, which is in particularly done for substances like aspirin, heroin and THC. This THC is nothing but the tetrahydrocannabinoid, which is isolated from cannabis and acts as an anti-inflammatory agent. So, with this we wind up the lecture on purification methods. These are the references: S.L. Dore, Biren Shah and Trees and Evans, and I thank for the patient hearing.